Good afternoon. Today we are going to see again some questions. Now these are numericals, I can say, and that is on Unit 2, shear force and bending moment diagrams. Now in this we have first the shear force at x-axis of the beam loaded and supported as shown in figure. So now we can come from left or we can come from right. So if I will take from left, then what we will get? So we will have this one M and we have this as X. So and then if we will write shear force, so shear force equal to 0. Because no load is between, so if I will mention it at some point, this is D and let this will be B, then there is no load between D to B, that is concentrated load, or no force is there between D to B. We have moment only, so we have shear force equal to 0. Then bending moment at x-axis for the beam loaded and supported as shown in figure. So now we are with same diagram. So we have this will be M over here, and then we have this will be x-axis. So now we have M is equal to minus M. So bending moment equal to minus M. What minus indicates M is in clockwise direction. This is my bending moment at x-axis for the beam loaded and supported as shown in figure. Then shear force left of C for the beam loaded and supported as shown in figure. So we have left of C. So if we have to consider left of C, then what part we have to consider? So if I will go for left part, then we have to consider this as 25 kilonewton meter. Distances are not required when we will talk about shear force if we know reactions. So we have this will be 4.44. And then if you will write shear force, then you have plus 4.44 kilonewton, that is upward. And then if we will come from this side, so left of C, so we have this will be then 30 kilonewton. And then we have this will be 25.56 kilonewton. And then if we will solve this, then we have shear force as, so we have downward plus minus 25.56. So we have 4.44 kilonewton plus means downward. So we have like this. So we have equal and opposite on this side. So we have value 4.44 kilonewton shear force left of C. And if we will go right of C, then that becomes 25.56 kilonewtons. Then bending moment left of C. So now left of C or right of C, we are going to be same because we know bending moment we have to find under the concentrated load. Then what value we will get? So bending moment equal to 4.44 into 2, sorry, into 3 plus 25. And then we have this will be 13.32 plus 25. So 38.32 kilonewton meter and plus that means we have clockwise. So you have to consider only that part. If I will show you here, then we have this will be 4.443 meters and then we have here 25 kilonewton meter. And then we have 4.44 into 3 plus 25 because this is also clockwise. Then shear force at 3 meter from support A of the beam loaded and supported as shown in figure. So 3 meter from A. So from A we have to consider 3 meters. So UDL we have to take this is of 2 meter. And if we will consider this, then we have this will be 100 kilonewton and then 2 meter we have UDL. So we have UDL and UDL intensity is 40 kilonewton per meter and this is of 2 meter. And then if we will find shear force, then we have 100 minus 40 into 2, 80 and then this will be 20 kilonewton. So shear force at 3 meter from support A is 20 kilonewtons. Then we have bending moment at 3 meter. So we have to go again same things. So we will have this as 100 kilonewton, and then at 3 meter. So we have this as 40 kilonewton meter. This is 2 meter. This is 1 meter. So bending moment we will get that is equal to 100 into 3 minus 40 into 2 into 1. So we have this as 300 minus 80, and then we will get it as 220 kilonewton meters. So bending moment at 3 meter from left support A, we have that is 220 kilonewton meter. Then bending moment is maximum at that dash distance. Now we have to consider some x distance. So let us we have this as 100 kilonewton. This is 1 meter, and that is from 1 meter we have UDL. Then we have this value that is equal to 40. This is x. So bending moment maximum at shear force 0. So we have to find out shear force 0 equal to 100 minus 40 into x, and therefore we will get 40x equal to 100, and x we will get 100 upon 40, and that is equal to 2.5 meters. Then maximum bending moment from support A, this will be 3.5 meters. So that we should be very careful with these all values. Then we have shear force at 3 meter from support A. Now we have this as 100. So 3 meter, if I will say, we have let us 3 meter over here. And if we will plot this, so I will plot this. So we will have in this fashion. So this is y. This is 3 meters. We have this as 100 kilonewtons. And this is UVL. Now how we will find y? So this is 100, 6. Then we can have y by, now I can say this as y by x if I will say. Then we have y by x, that is equal to 100 by 6. Now this x we have 3. So y by 3 is equal to 100 by 6. 3 ones are 3, 3 twos are. So this comes 50. Or you can say half distance we have 50. And then we have to find out shear force. So shear force equal to 100 minus half x we have 3, y we have 50. And then we can have this value that is equal to 100 minus 2 ones are 2, 225, so 75. So we have 25 kilonewton. So shear force at 3 meter from support A is 25 kilonewton. Then we have to find bending moment at 3 meters. Now we are going to use the same. So how we will get now then bending moment equal to, now we have 100 into 3 minus this value of triangle as it is half into 3 into 50, and it will act here, and we have this distance from right angle, so this will be 1/3 of 3, and that is 1 meter, and therefore we have into 1, and then we will get it as 300 minus, so 225, so 75, and we will get that is 225 kilonewton meters. And then we have last, that is maximum bending moment. Bending moment is maximum at dash dash meter from support B. Now try to understand, the confusing question is there, you have to find from B. So it is better we have to find from A, because we can go similar triangles, and therefore consider from A. Once I know value from A, I can subtract from 6 meter, I will get value from B. So let we will say we have x meter from A, where we have shear force 0. We know where we will get maximum bending moment at shear force 0. So we have this will be 100 kilonewton. This we have x, and this we have y. Now we know we have y by x equal to 100 by 6. And from this we will get y is equal to 2 3s are 50 by 3 into x. So y we have 50 by 3 into x. And then shear force 0 we have to find out. So shear force equal to 0, which is equal to 100 minus half into x into y. And then if we will put it 100 minus half into x into 50 by 3 into x, and then we will get it as, let us, we will keep this will be 25, and then we have 25x square by 3, and that is equal to 100. And then we will get it as, this value we will get, that is equal to 25 fours, and then x square will be 12, and x we will get it as 3.464 meters, which is from A. And then from B, maximum bending moment is at 6 minus 3.464, which is equal to, so we have 3.5, 2.5. So we can have 4, 6, 1, 7, 3, 1, 5, 5, and 1, 2.536 meters. So from here we will get 2.536 meters. And if you have to find maximum bending moment, then we can have maximum bending moment that is equal to 100 into 3.464 minus 1 half into, now x is 3.464 into y we have 50 by 3 into 3.464, and one third of this 3.464 by 3, and then we will get this value because it will act at centroid, which will be x by 3. So 3.464 by 3, and we will get 230.93 kilonewton meters. So we can frame a number of questions, and that we have to be very clear with the concept. So do not read number of MCQs. Better go for basics and try to understand what will be the polynomial function between the loads, what will be polynomial function between the region, and then you are in position to solve the MCQs. So thank you. We will stop here only.